Reviewing buckling modes in large FEA models can take hours across subcases, increments, and manual screenshots. In this video, we show you how to reduce that workload using a Python script with NaxTo. Select a specific part of the model, filter only the modes that buckle in that area, and generate the screenshots automatically. In this example, we work with a nastran model, and in our case, we load the .op2 file directly so that mesh and results are loaded at once. The goal is not to review all buckling modes of the model, but to focus on one specific region, the area we leave visible in NaxToView. That's why we first define the part we want to inspect and keep only those elements visible in the scene. In this case, this 𝗵𝗴𝗴. For this example, we use NaxToPy together with NumPy as the main libraries in our script. The script is built around a few key NaxToPy functions that automate the buckling post-processing workflow. First, the _set_legend function defines how we want the legend to look, colors, fonts, position, and value format, so that all images keep a consistent presentation. The getNodes from visible elements function retrieves the nodes that belong to the elements visible in the scene. In other words, it focuses only on the part of the model we have left active in NaxToView. The compute_buckling_eigenvectors function filters buckling modes based on the eigenvalue and the eigenvector magnitude in that area. This way, we keep only the modes that show relevant buckling in the region we are analyzing. Finally, the export_buckling_screenshots function automatically generates PNG screenshots with the magnitude_decontour eigenvector module for each mode that passes the filter, including the scalar legend we configured before. The main function brings everything together. It opens the active scene model, computes the nodes of the visible elements, applies the buckling filters, and calls the screenshot export using the folder we have selected. From NaxToView, we run the script directly. When we launch it, a dialog opens so we can choose the folder where the screenshots will be stored. The script loops through subcases and increments and generates only the images corresponding to significant buckling modes in the visible part of the model. In the original example, we had 9 subcases and several increments per subcase. Instead of reviewing everything manually, the script filters and automatically produces only the 17 images we care about. With NaxTo, you can build this kind of pipeline to automate your post-processing. This is just a small example of what you can do with NaxTo. Download it, try this example, and tell us what you'd like to automate next.